All right, welcome to day 5. You got packet page 33 to 35 for homework, which you'll upload directly to Schoology as a single PDF. We are going to be using our compasses today, so you will need your compass. We'll also need a straight edge. Often people just use the side of their calculator cover, but if you would like a different straight edge, you can. And we've got a warm up, so what I'd like you to do is pause the video right here and try your warm-up on the warm-up sheet for Wednesday. Once you have finished doing the warm-up, you can unpause the video and watch the solutions to the warm-up. So again, go ahead and pause the video right now in order to do the warm-up. All right, so which line is parallel to y equals 3? Y equals 3 is a horizontal line that is passing through the y-axis at 3. So we would want another horizontal line, so that would be y equals 7. X equals 3 would be a vertical line, and B and D, those would be slanted lines. And 2, write the equation of the line in slope-intercept form that is perpendicular to the line y equals 1/2 x plus 2 and goes through -5, 3. So we want perpendicular, so we need to do our negative reciprocal slope. So our perpendicular slope would equal -2. We would start out in point slope form, so y minus 3 is equal to -2 times x plus 5. It's the opposite signs. But we wanted the answer to be in slope intercept form, so we'll distribute the -2. So that's y minus 3 is -2x minus 10. And we'll add the 3 over. So we'll have y equals -2x minus 7. All right, moving over to your homework. We wanted parallel to AB and contains point C. So we wanted same slope, so you could have that top version. Now, x minus 0 is just x, so you could have also just had it as the -2x, the middle one. Or if you had gotten y by itself to be in slope-intercept form, you could have had the bottom option in A. So each of the boxed ones, when there's 2 boxed ones, either one would be correct. So if you have either of those, that's okay. So in B, we had to first get y by itself, so we're in slope-intercept form. Slope is 1/2, so we use that down here. Then we brought our y and our x values down. Remember, in the basic setup, you're subtracting from the y and x. That's why it switches signs. So you could have just left it in point slope form or distributed and added the 4 over to put it in slope intercept. Okay, either of those boxed ones would be full credit. In 2, we want perpendicular, so we need to flip and negate the slope. So we had a -2 slope we'd use. Put in your points. Easiest way, just leave it as point slope form unless they asked you to put in slope intercept form. Now, y minus 0 is just y, so that would have been in point slope form also, or you could have distributed through to get the slope intercept form. Any of those boxed ones are okay. Again, the y equals mx plus b is slope intercept. So if they asked that, then you would have to distribute and move everything over. So b, get y by itself, -2, so flip and negate it. That'd be positive 1/2, because this was really -2 over 1. Put in your slope, put in your 4s. They're -4s because in the formula it's got a minus. And you could leave it right like that as point slope, or distribute the half and add the 4 over to get our slope intercept of 1/2 x plus 2. In 3, we first have to figure out the slope of the original. We get -5/4, so the negative reciprocal of that would be +4/5. So that is our perpendicular slope, and we want it to pass through the midpoint. So we've got to do our midpoint formula of adding the x's and dividing by 2, adding the y's and dividing by 2, and that gives us our midpoint of 5/4. We'll now use your slope of 4/5 and your point of 5/4. You can leave it in point slope form, that first box, or if you chose to get it in slope intercept, it would be the bottom box. All right, so we're going to be on packet page 25 today, and we are going to use our compass. So when you use your compass, we need to be able to draw arcs and circles. So just to give you an idea of how to hold the compass and everything, I'm going to show you a quick version of that. So here's my compass. I've got my piece of paper. You've got your packets on page 25. You're going to practice these circles. So when I hold my compass, I like to hold it with 2 fingers close down to the point in the pencil. So I'll put them on the paper, but I'm putting pressure into the point and not really any pressure into the pencil. The pencil is just lightly touching the paper. So what I'll do is while putting pressure in the point, I'll take the pencil and I'll swoop it up and swoop it down. And then I switch which hands are holding each, but making sure the point does not move. So now I have my right hand on the point and I'm putting pressure into the point, so the metal part, and then I lightly swoop the pencil part, and it's kind of light because it's in pencil, but there I have my circle. So that's the way that I like to hold the compass when doing this. So pause the video and make 3 different circles, all with different radii. So switch your compass, how far open it is, so you can make them with different radii. So pause the video. When you're done doing those 3, you can restart the video. Okay, so hopefully you have those 3 circles and you feel comfortable with drawing arcs with the circles. So an important thing when we're doing these constructions, we never want to erase what we've drawn with our compass. Those are called construction marks. That's basically your work in these problems. And in math, we always have to show work, so you need to make sure you always leave those. Never erase those construction marks. So we're going to show you a few basic constructions in today's lesson. So if we move to the next page, page 26, the first one we're going to show you is how to construct a segment of a given length. So you need your compass and also a straight edge. Again, you can use the cover of your calculator if you want, or some other straight edge. Now we say a straight edge because if you use a ruler, we're not using the measuring aspects of the ruler. When we do constructions, we always measure the length with the compass. So to construct a segment with a given length, we want to copy the length of that segment. So first thing you do is using your straight edge, make a line segment that's longer than the one that we want to copy. Now it's helpful to have, first off, I would say be using pencil with these, but you want to have an additional pencil probably in addition to the one that's in your compass. It's usually easier to do that than have to draw with the one with your compass. So what you're going to do is you're going to set your compass so that it is the length of your original line segment. So my compass is now opened up as wide as that line is. What you're going to do now is bring it down to one of the end points of your line segment. It doesn't matter which one, and you'll put the point. So when I say the point, I mean the metal part. You'll put the point on one of the end points of the line segment, and then while holding that, just do a little mark to mark off the length. So what we have just done is this original line segment is now congruent to that line segment length. And you don't have to put those little marks in. I just put them in to show which part was the congruent part. Now that arc would be considered our construction mark. We need to leave that in. That's our work showing we've just created a segment that is the same length. All right, so that's the most basic construction. So our next one, we're going to copy an angle. To copy an angle, it means we want to take an angle with the exact same measure and put it somewhere else on our paper. It is just the measure of the angle. Those rays, we could draw the sides of the angle longer or shorter because they're just going to have arrows on the end anyway. So that part doesn't matter, but it's the measure of the angle that we are copying. So to copy an angle, first thing we want to do is we take our straight edge and we draw ourselves a line segment. Next thing we're going to do is we're going to go over to our original angle, and you're going to put your point on the vertex of the angle. And then what we're going to do is we're going to swoop our compass so it hits the angle in two spots, once on each side. After you've done that, keep your compass open at the exact same amount, and we're going to go over to the end point of our line segment, and we're going to swoop that same arc. And make sure you swoop it enough. Don't make it too small. It's better to be too much than too little. Then what we're going to do is we're going to go over and we're going to put our point on one of the intersections. And you'll put your pencil on the other intersection. And make sure it's exactly on there. Okay, we need it to be the exact amount. And then keeping your compass the same, we're going to go and we're going to put that point on the new intersection that was created. And then just do a little swoop with your compass to create another intersection. That intersection that we just created, we will connect a line from our endpoint to there. And it's a little hard to do on the smartboard, but it's easier with your straight edge. Make sure you're using your straight edge anytime you're drawing a line. So connect from the endpoint to that new intersection, and now we have just created an angle that is exactly identical in measure to the original angle. So that's called copying an angle. Now the nice thing about doing this on a Wednesday is as you're doing your homework tonight, if you're stuck, you could always just replay this video to see how to do the certain constructions. If you flip to the next page, page 27, there's step-by-step directions. Or remember, you can always just replay this video and you can see me work it out. So we're going to practice to copy the angle again. Now, when you copy it, it can be in any orientation. It doesn't have to match the orientation that's there. So we're going to copy this given angle. So we're going to draw our line segment. So I'm just going to draw my line segment down here like that. And you should be doing that when you draw any segments, you should be using your straight edge. Oops. So now what we have to do is we need to put our point on the vertex of the angle, and we need to swoop any convenient arc so that it intersects twice on the sides of our angles. We'll then take our compass, open the exact same amount. We'll put our point on the end point, and we'll swoop that same arc. Make sure you swoop it big enough because we're going to want to get an intersection eventually. Now we bring our compass back over and we have to set it so that it is the exact width of our intersections. And we want it to be exact. Okay, so once you have it as the exact width, we're going to go over here. And you want to put your point on the intersection that was created. And keeping your compass the same, swoop an arc so you get another intersection. That other intersection is where you'll draw a line from the end point through. So using your straight edge, start at your end point, go right through the intersection point, and that is your angle that is copied. We copied a congruent angle of the exact same measure. So we'll do that another time to practice. So copy the given angle. We'll go through a little quicker here. In the video, if I'm ever going too quickly, feel free to pause it so you can finish a step before it goes on. So we'll draw our line segment with your straight edge. We'll go over here. We'll put our point on the vertex, and we'll make any convenient arc. We'll move over, put our point on the end point, make that same size arc on our angle we're trying to copy. Then set your compass so that it's open as wide as the two intersections are, and make sure it's right on them. Then bring it over and put your point on the intersection we created. Swoop through, and notice I didn't get an intersection. So that means I didn't make my other arc big enough. So I've got to go back, and I've got to reset my compass to that original arc. So this is the why I mentioned to make it as big as, make the arc pretty big here, because now I have to go through and redo this to get my intersection. So if I just made that bigger in the beginning, it would have saved me some work. So you put your, start your segment at the end point, and it goes through the intersection, and you now have your copied angle. All right, so that's a common construction. The next one on the bottom of page 28 is we're going to bisect a segment. So bisecting a segment, these motions are used in lots of different constructions. So we're going to start out, we want our compass has to be open more than halfway. So make sure it's open more than halfway. You put your point on one end point. When it's open more than halfway, we need to swoop down and swoop up and make sure that it is more than half of a circle. Then we'll flip-flop. We'll put our point on the other side, keeping your compass exactly the same amount opened. Swoop up and swoop down, and you should get two intersections. All we do is with our straight edge, we draw a line straight through those. And I missed my spot a little bit. Straight through those two intersections, and that is your perpendicular bisector. So that segment I just drew vertically, it cuts the original segment in half, and it forms a right angle with it. The only way to bisect a segment, or in other words, cut a segment in half, is to do the perpendicular bisector. Again, at any point, if I'm going too quickly on the steps, pause it until you complete the step after I've talked about it, and then hit play again. There's the written out directions, or you could always just replay the video. So we'll practice this a couple more times. So we're going to put our point on the end point, open your compass more than halfway, swoop around a half a circle, and then we'll flip-flop. Put your point on the other end point, keeping it open the same amount, swoop it more than halfway, we get two intersections. With your straight edge, draw a line that goes right through those two intersections, and that's your perpendicular bisector. It cuts the original segment in half and forms a right angle with the original segment. And we'll try that once more, a third time. So point on the end point. Make sure you're over halfway. Swoop around a half a circle. We'll flip-flop, put your point on the end point. Swoop about a half a circle to get two intersections. And then use your straight edge to connect those two intersection points. That's kind of hard to do on the smartboard, so I have to adjust mine after I'm drawing it in. But we should go through those two intersections, and that cuts our original line segment in half and forms a right angle. So again, at any time as we're doing this, pause if you need time to actually draw yours. So one last construction for today is the angle bisector. It's another common construction. So angle bisector cuts an angle in half. So we start out and we put our point on the vertex and open up our compass and do any convenient arc. And then what we do is we go to each of our intersections and we do a little swoop towards the middle. Keep your compass the same when you're doing these two swoops. And we're trying to then produce that intersection out there. We connect our vertex to that intersection, and that is your angle bisector. So what that has just done, it has created two congruent angles. So again, we did a convenient arc, and then we went to each of the intersections that arc was created, made arcs from those that are the same length out towards the middle, and then just connected the vertex through there. On the top of page 31, you have written out directions for that if you prefer to follow that as opposed to following the video. And we'll practice this twice more. So put your point on the vertex. The vertex is that corner point of the angle. Open up your compass. And you want to open it up enough so it's not crammed in really tight, but you also don't want it too huge that it's like going to go off the page. So open up your compass, do a convenient arc. And we're going to go to each of our intersection points. And do a swoop in the middle. And you want to try and make sure you're right on it. Do a swoop in the middle. That'll get us an intersection. And then we just connect from the vertex. Oops. That was supposed to be a line instead of the pen. So then we connect from the vertex to the intersection, and that is our angle bisector. The angle bisector cuts the angle into two congruent angles. So one last time practicing this one, we'll put our point on the vertex. As a reminder, as we're doing these, if I'm going too fast, just pause the video after each step that I show so you have some time to do it. So point on the vertex, I'm going to make a convenient arc. By that, it's meant any size arc you want. I'll go to one intersection point. I'll make an arc towards the middle. I'll go to the other intersection point. I'll make an arc towards the middle. Notice those two things cross. From there, I'll connect a line from the vertex through those intersection points, and that's my angle bisector. What that's created is two congruent angles. Those little arcs signify congruence for angles. So as you're doing your homework tonight, you have this video. You could rewatch it as you're doing it. See if you can do it without following along with the video. But if you get stuck, you can watch the video to refresh your memory.